In this video, we will look at how to transform points of a specified function. The example we're interested in is the function x squared. It's a quadratic function. And we're going to look at all the basic rules for transforming points that we're learning about in this course. So the first one that we're looking at is if we want to do a vertical shift of the graph, we want to shift it up 5 units. What we're doing is adding 5 to the original function. So in terms of points, this would be the same as adding 5 to the y value of a point. So like 1, 1 is a point on the function x squared. If x is 1, then 1 squared would be 1, the y value. So this is a point that's on the original function f of x equals x squared. So when we're shifting up 5 units by adding 5 to the function, we are just, in terms of points, adding 5 to the y value to shift that point up. So we add 5 to the y value and we end up with a new point, the transform function, x squared plus 5. 1, 1 would become the point 1, 6. Because we shifted the y value up 5 units. If we did a vertical shift down 5 units, then we'd be subtracting 5 from the function, and in terms of points, subtracting 5 from the y value of each point. So given the point 1, 1, we'd subtract 5 from the y value, 1, and we'd end up with the new point 1, negative 4. So if we shifted down and we got this transformed function x squared minus 5, we'd be shifting this point 1, 1 of the original function down to the point 1, negative 4. If we want to do a horizontal shift left 5 units, since we're going to the left, even though it says plus 5 in the function, we would actually be subtracting to go left 5 units. We'd be subtracting 5 from the x value of the point. So we would subtract 5 and we'd be shifting the point 1, 1 to negative 4, 1. 0.11 would become negative 4, 1 on the new function x plus 5 squared. A horizontal shift right 5 units in the function looks like this. We'd be saying instead of x squared, x minus 5 squared. But since we're going right 5 units, we would actually be adding 5 to the x value of the point. So given the point 1, 1 from the original function, we would add 5 to 1 to get the point where that point would be on the new function, which would be at the point 6, 1. If we want to do a vertical stretch such that a, which is in terms of if we have the function a f of x, such that a f of x, if a is greater than 0, multiplying this number by the function, like it is here, 5 is greater than 0, then what we're going to do for vertical is we're changing the y value and we're multiplying, just like we're multiplying the function by 5, we have to multiply the y value of the point by 5. So the new point on the new function would be 1, 5. 1, 1 would become 1, 5 on the new function 5 f of x. So this would be 5x squared. For a vertical compression now, if a, the value that's multiplied by the function, is greater than 0, less than 1, like it is here, is 1/5, what we would be doing is multiplying the y value by 1/5. So to transfer the point 1, 1 of the original function to the new function 1/5 x squared, we'd have to multiply the y value by 1/5 and get the point 1, 1/5. 1, 1 would become the point 1, 1/5 on our transform function. Horizontal compression is when b greater than 0, okay, such that we have f of bx. So instead of multiplying on the outside of the function, we're multiplying inside by the x value. And in this case, if b is greater than 5, what we're actually going to do, we're compressing, is multiply by 1/5. We're dividing by 5 instead of multiplying by 5. So we multiply the x value by 1/5 if the b value is greater than 0. So 1, 1 transforms to the point 1/5, 1. Here, This time we have a value that's less than 1 and greater than 0. So instead of multiplying by 1/5, we're going to be, because we're actually dividing by that value, we're going to be multiplying by 5, the x value by 5 here. So 1, 1 would become 5, 1 on the new function, which is 1/5 x to the power of 2, or 1 over 25 x squared.